Greetings. This is called Project Kavaratti with a very ambitious title. This was presented at the Sree Narayana Gurukulam Engineering College near the city of Kochi in Kerala, India, on April 27th, 2023. So this is a university-based, university-led project with the very ambitious goal of beginning the process of reversing global warming. And that process has to start with very small, careful steps, small design, build, fly projects leading to a global scale. Our initial focus will be on meteorology, astronomy, drone swarms, UAV swarms, and environmental improvement. Please observe these two closed loops that I show here, one in each hemisphere. These are called peak summer followers. Reflective vehicles will follow the location of peak summer sunlight. April 27th is close to peak summer at about 10 degrees north latitude where I am presenting this. The sun is right above us. So what you're seeing here is an 8-meter wingspan biplane called a flying leaflet. The upper wing is an ultralight reflective sheet. It flies at about the same speed as an auto rickshaw, very slow. But that is enough to climb, as you will see in just a moment. It takes off, lifts off, and climbs. This is basically a hands-off takeoff. It flies itself more or less. Initial tests are being planned at Amrita Vishwavidyalaya near Coimbatore, India, and at IIT Madras. These will be radio controlled. Later ones will be autonomous UAVs with specified missions, but still monitored from the ground. The vehicle is built of a carbon composite truss structure with photovoltaic cells covering the lower wing and tail. It has two BLDC, brushless DC motors operating propellers. Although 8 meters in span, its weight is 17 to 24 kilograms. So it stays under the 25 kilogram limit of very small UAVs. It can take off across a runway if needed. It can land anywhere. This is a quarter scale model of the 32 meter span real vehicle. A cricket field would be perfectly adequate even for the full scale vehicle. So let's talk for a moment about this strange contraption will help reverse global warming, if ever it comes to that and nations decide that would be a good option. In the full architecture, the 32 meter span vehicle, the flying leaflet, takes off, climbs to 100,000 feet or 30.5 kilometers inside 8 hours and joins up with 10 other flying leaflets to form a flying leaf. 8 of the 11 frames return, leaving the sheets up there, sheets and controls up there to continue the process next day. So only 3 of the flying leaflet lower wings and propellers and motors are needed to power a flying leaf. The flying leaves form into swarms, and these are able to stay up above 60,000 feet or 18.3 kilometers, gliding through a 12-hour night with no other energy storage except potential energy. Let's talk for a moment about how this strange contraption again, or why we are doing this. In my opinion, today we are not on a trajectory to reduce the rate of increase, much less reverse global warming. Reality is that industrialization and better living standards, such as air conditioning, jet travel, etc., are dumping waste heat into the atmosphere at a fairly high rate. Now, greenhouse gases such as carbon dioxide and methane absorb the infrared wavelengths in the spectrum of the radiation that is coming off the surface or coming down from the sun, and that gets all the attention. So our objective is a safe, viable, well understood option to reduce net atmospheric heating, the balance between what comes in and what goes out, which is right now biased in favor of what comes in. It's not enough is going out right now. We want this option to match the priorities of most nations and to hurt no one. We have to broaden the present scheme of carbon credits, which everybody knows about, to perhaps the United Nations Sustainable Development Goals, which also everyone knows about, and start recognizing perhaps some kind of nature credits rather than just carbon credits, including reflecting sunlight as equivalent to having the same benefit as reducing carbon. So climate action does occur on the UN's SDGs. It's number 13 on that list out of 17. These are all things that you want in your program as any modern educational institution or technological institution. These are all on this list as well. So welcome to what we call the glitter belt. It has two types of vehicles and only two types. The 32-meter span biplanes called flying leaflets are used to assemble the 352-meter span flying leaves. Each flying leaf reflects roughly 62 megawatt of solar energy all day. For the first several years, this is just a global continuous atmospheric mapping project. Flying leaf swarms will be used to get data not only about themselves and their effects, but also to map weather and climate in unprecedented detail and unprecedented access. Because there's really no other way to get out to the remote southern oceans, for example, to collect any kind of useful data. That is the first requirement for climate modeling. And if this is the only approach to global warming that humanity is able to devise, then I have shown what is needed. The red circles on this graph are the number of flying leaflets built and launched each year. So these are a few million per year all around the world. The blue triangles denote the total number of flying leaves reflecting sunlight each year, and that grows as you build up the system and reaches a steady state. And then it comes down. You bring it down. The black dashed line is the heat level in the atmosphere corresponding to which year. So it initially rises at the start. Then we bring it down steadily to the 1990 level if needed by 2055 if we start building next year, which is why there is some urgency. Of course, reforestation, and emission controls will, I hope, kick in long before that, and we can recycle these flying leaf vehicles, except those which may be used for other purposes, such as continued meteorology. Now, the National Academies of the USA provided, they got a little bit worried at the prospect of people starting out their own climate change projects and block sunlight, etc., etc. So they provided guidance on projects that reflect sunlight. So our initial plan is to use this as a strictly meteorology climate sensing platforms through the development phase, so that if and when it is time to scale up, decision makers are ready with the data. And you can see some of these gadgets. This is what it looks like, 100,000 feet or way above the surface of the Earth. You see that the sky looks pretty black because there's nothing left up there to reflect anything or scatter any light. All this sounds enormously grandiose, but we've done the numbers. It is doable. And I can discuss that in much more detail. How can such a thing be done? Well, you plan in detail, you talk to everyone, you decide on a process, and you think and think some more, and you worry a lot, and then you start implementing, and you keep implementing. We have been doing this for some years. In addition to what I list here, there are patents and presentations and other things in progress. Yes, I do have a detailed countdown list, and it's getting bigger and bigger in detail. So what is the process? The first 8-meter span flight test model is being built or being planned to be built, I should say. They are still in the design simulation phase and looking at what parts to order and from where and all that, by a student team at IIT Madras and at Amrita Vishwavidyalaya near Coimbatore. And you are all most welcome to join. The first swarm, consisting of 352-meter flying leaf vehicles, is being analyzed by a team at IIT Mumbai, IITB. The first 4-meter UAV for flight control development is being designed by Amrita Vishwavidyalaya. We need your brain power and dedication. Beyond basic testing and rendezvous demonstrations at Chennai or anywhere else and over the ocean, we plan some tests going to high altitudes before we try what I will call a trip to the Lakshadweep and back, which is the Kavaratti project, and then on to other places around the world, into the southern hemisphere. How can colleges help in this? Well, colleges are key. You are open to ideas. You can conduct discussions that most organizations cannot conduct. You have laboratories, you have testing grounds, you have enthusiastic people. You can bring in people who might not otherwise come together or even talk to each other, and they can discuss things freely here. Students have immense power, believe it or not, and faculty have respect as honest, unbiased, and thoughtful people. So now let's talk about Kavaratti. Kavaratti is the capital of the Lakshadweep Islands. Lakshadweep literally means 100,000 islands. There may not be 100,000 today because the sea level has risen a lot in the past few thousand years, and there may be a lot fewer in the near future because the average altitude of the Lakshadweep is on the order of 1 meter above sea level, above mean sea level. Much of it is sandy beaches and very, very, very low-lying land. Kavaratti has a helipad. It does not have an airport runway as such, but it has a helipad. Now Kavaratti was chosen also because it is closest from the Kerala coast, the west coast of mainland of India. Agatti is the closest airport, but that is another 56 kilometers away. That sounds pretty close, doesn't it? But if you are solar powered and you're flying at 30 kilometers an hour, That's 2 more hours of sunlight than what we may have, especially if the wind is not favorable to us. So I'm now practicing the procedure to land at the Agati helipad, which I assume it's not too different from the approach and mechanics of the Kavaratti helipad. The Kavaratti helipad unfortunately is not available on the flight simulator, but we have pictures from above as well as the approaches. So our present route assumes a start from the IIT Madras campus. It could start from other places, and we may have multiple Kavaratti or other projects. Things could be greatly simplified, but we really do want to spend some time doing this set of tests, because we want to steadily improve the confidence of the team. We want to get any remaining bugs out of there, and we want to fly steadily to higher altitudes, all these things. And we want to have a lot of landings before we are willing finally to let the vehicle go completely on its own, far out of our vision. So this is the present sequence for the Kavaratti project. You should read from the bottom up. The green items are where we have already reached, and we have come a very long way. These things have been done over the past few years, and they represent very major steps in reducing the uncertainties. So if you're done looking at that, in summary then, it is possible to stop global warming and then reverse it back to 1990 levels, as they wanted to do when the original Kyoto protocols were signed back in 1992. It takes a lot of work, but it is straightforward and well understood technology. It requires collaboration, it requires faith and open interactions with people all over the world. And it is truly a dream project for me, and I certainly hope it interests at least a few students and faculty here and all over the world. Whenever people allow me, I hope to make a similar pitch at other institutions before we approach the government, and then through the government, the United Nations, and governments, and through the United Nations. And let me mention here the support that I have received. Oh, by the way, you can be watching a landing while I talk. Let me mention here the support that I have received from the Takshashila Foundation in the United States, and its President Dr. Adarsh Deepak, who passed away this December 5th, 2022, and Vice President Mr. Ravi Deepak. Thank you. I hope we can have lots of discussion on this, and that there are many questions which I'd be delighted to answer. So you can see the process of landing. You shut off the power and you flare at the very last moment, and then if you shut off the engines, which I haven't quite mastered the art of doing that, and apply brakes, and it'll stop without too much trouble. Thank you very much.